minutes or something.
So we can start?
Yeah, we can start.
You want to lock the door or?
No, I think people are gonna drop in. I think more
Too
people.
late. No, too late.
Someone steals your wisdom.
All right. Okay.
Well, I'll do a quick intro, then I'll just so you can go.
Sure.
All right. So thank you everybody for coming today. For those who don't know who I am, my name is Tai Tiang from Test Force. We're a provider of test and measurement equipment here in Canada. We've been able to help York through the years, mainly on your science departments, historically, providing things like oscilloscopes, power supplies, specialized measurement equipment, RF equipment, GPS and GNSS test equipment, and more recently on the ECE side, things like probe stations, more oscilloscopes, spectrum analyzers, all sorts of different test tools. I'm here today with my colleague from MPI, Brian. I'll let him take over in just 1 second. So what we're going to do today is kind of explain what we have here in terms of a probe station, best practices for using it. We're actually going to do some probing as well. And then we're going to kind of have an open session where people can come up and try the station, right?
Perfect.
And then we'll set up this station while we're doing that in parallel, so then people can take a look at both stations. And then Brian will go over kind of the differences between the probe stations and all the wonderful things you'll be able to measure with the probe stations. All right.
Fantastic.
Go ahead, Brian.
All right, thank you, Ty. Well done. Yeah, and thank you everybody for coming. I'm planning on going over the impact, the ITS150 station from MPI, and just talk about basically the operational training of the station, how you use the station, how you do probing, some more information on what the station is capable of. Be right up front as far as specifics of measurements and what type of measurements. It's not so much my gig. My gig is more nuts and bolts, show you how to use it. So if you have specific questions about measurements or particular measurement types, I can take a stab at it, but there's a good chance I'm probably not going to be able to answer your question on that. We can talk about it a little bit for sure. So let me get right into it. And I'll just go from the top to the bottom. So I have a camera on top, video camera that outputs to the monitor here. It's a 1080i HDMI camera, and that will view down through a stereo zoom microscope. And you have the option of viewing your substrate, whatever you have on a microscope or whatever you're probing, either from the monitor or through the eyepieces on the microscope. The microscope also has a zoom on it on the side. It's 1 to 4.5x zoom. There's also a focus rack in the back, allow you to focus up and down. And there's also an XY movement as well. It's not a lead screw, it works on an air bearing, and there's a handle on the left side. You probably can't see it, but if you flip the scope switch down here, it'll enable this air bearing, and when you have the microscope where you want it, you flip the microscope switch back up. And because I have the vacuum pump off, that's not going to lock. I want to turn that back off, but just for demonstration purposes. And now it's locked. Turn that off, and it'll float around. And it'll lock back in place once you have the microscope in place. And I'm just going to shut off the vacuum pump for now, just because it makes a little bit of noise. Let's see. It also has a tilt function. There's not much room to work in here with the microscope in place, so tilting it back will just allow you a little more access in here to move your probes out of the way or do whatever work you need to do with your probes and the cables. It'll just give you a little bit more space to work.
Those of us who are not from RF background, so could you throw some light the main purpose of these probes?
The main
Purpose of these probes?
Really? Not sure I totally understand your question. As far as testing in devices or?
Yeah, so these probes are RF probes, and what's the main purpose, or what do they probe in RF?
It's mainly for high frequency probing. The biggest thing I come up with is like wireless devices or cellular devices that work in the gigahertz range. You can use RF probes from DC, all the way up to the terahertz range, and everything in between. I don't know if that quite answers your question or not.
Somebody else.
RF is radio frequency, it's just high frequency probing. Okay,
Yeah, so we're probing for what? Signals, if they are,
do you want to field that one? I don't know.
Just probes, just needles, you probe a new device and
but we're probing for what?
to make an electrical connection, and then you can run whatever voltage, current, any electrical measure.
So we're just making the contact and then applying our own signals.
Exactly, so you don't have to wire bond the wire to it, you just push your probes into it. That's
So mainly for test purposes.
exactly, yeah.
You can test your device or do characterization to see how your device behaves. Yeah, a number of different aspects of it.
You can change the frequencies, we can change the frequencies, and then.
Absolutely, yeah, and with this system, I believe you have 26 gigahertz probes, so good for, basically DC up to 26 gigahertz. And everything in between. Alright, let's see here. We talked a little bit about the microscope. Last thing on the microscope, there's a ring light on the bottom. There's a control pad on the side with a variable intensity. Put this guy back down. And that's going to be the surface of the chuck right there. We'll use a monitor, and then you have your needles in there, and you'll see your probe needles on the monitor, and we'll look at that a little bit later. Some people, typically older folks actually, where we didn't have digital cameras in the past, and we only had eyepieces. If you want to use eyepieces, there's a shutter on the side that you flip over, and it'll flip between the camera and the eyepieces, so you can look through the eyepieces. You can't do both at once, so just keep that in mind.
Right?
It's, oh yeah, you want to take a look?
Yeah.
You see it?
Maybe take off your glasses.
We got it? Yeah, it's pretty small in there. Oh, yeah, yeah. Okay. Scares me there for a minute. Okay. Put it on there so I can look at the monitors. All right.
So which knob you press to switch?
So yeah, it's a silver lever
Oh, this
on the right side. Yep. It's just two positions. It's a slide, but there's really only two positions to it. All the way towards the back or all the way towards the front. Oh, my goodness. And we got the zoom button again on the side. Zooming in, you might have to change focus slightly. Yep. You might have to change it a little bit. If we go down a little bit more, you have the probe platen here. So this is where your positioners are going to sit. And basically, positioner, in this case, it's got a magnetic base to it. And you rotate the lever in one direction, will align the magnets, so it'll be a very, very strong magnetic force. You throw the lever the other way, it will turn off the magnets, quote unquote, but there'll still be a little bit of residual magnetism there, it won't completely go away. So it does take a little bit of force to pull it off and to move it around as you need to. There's a thumb screw on the side. If you ever have a need, you can pop the arm itself off. There is cable tension relief here. So your RF cable, your probe would be mounted here, and then your cable would come up, and you could use strain relief right there. So that way, I know particularly like high frequency measurements, if your cables are moving around with relation to your probe, it can affect your measurements. And with this setup, it'll keep the cable and the probe moving together, which is very, very important, as I understand, for high frequency measurements. Another feature on this arm, there's a thumb screw here. This is a little bit hard to describe, but there is a, how do you want to call it, a solid area and a not filled area, a filled and a not filled, and it's a couple,
Very scientific.
area like that. So, and so the not filled one, there's an arrow indicating clockwise, and then there's a filled arrow, if you will, rotating in the opposite direction. That corresponds on the front here with how this mount is going to rotate. So if you rotate the not filled arrow, the blank one, it's going to want to rotate to where it's not filled, if you will, the blank. And then the white filled here, if you rotate the white filled arrow, it's going to rotate the other direction. So and that's just for planarizing your RF probe. Typically with an RF probe, you got 3 probe tips, and you want all 3 probe tips to land at the same time. You don't want them coming down like this. You want them coming down together all at the same time. Very, very important to have equal pressure in all probes.
Can you show me how to put the probe there? How to connect the probe? Can you show me?
Oh yeah. So the RF probe. Actually, we should use the one that up there. We break that one. It's not too bad. Right?
You don't want it? Okay, it's,
Okay, so this is sealed and on it is sealed. So if you guys can see, there's basically 2 mounts, 2 screw mounts, bolt mounts on the probe. The probe itself is right in the front, very small, and then it's going to mount to these 2 screw points right here. And then you have your electrical cable connection right in the top. There's a cover over it right now, but typically like an SMA type connector.
I see.
It's going to be right there at the top. Yep.
There are 3 or 1 probes there.
So on this one, there's actually 3 probes on the tip.
On the tip, there are 3 probes.
There are 3 probes down there,
Right next to each other.
all right next to each other. Yeah, you can see it on the monitor, but I don't know, unless your eyes are very good, I can't see them and stuff.
Yeah, I see
But
one.
if you want to pass them around, take a look at. Actually, you can pass both these around. Yeah, let's take a look at them.
Just a probe, right? Yeah, 3 tips.
How many sides do we have? Ty,
yes.
you know the tip size?
They're a 100 micron, like the pitch.
The pitch size.
I don't know what the actual tip radiuses are. But
Actual radius is how, you know?
I know the pitch is 100 microns. Like, these ones are GSG.
I don't know if
100 microns.
it says.
I don't know what the pitch, the actual, the tip.
Tip size, I don't
And
either.
you know the material of the tip?
I can get you all those details.
Yeah, because this is very important.
For the RF ones or for the DC probes?
Both.
Okay, the DCs are tungsten and they're 7 micron radius. Wait, is it radius by diameter? Which one do you guys do? But I remember
Radius.
Okay, then 7 microns radius.
You have 2 of those, yeah, but I guess there's supposed to be 2 more coming. There was a,
Yeah, so these ones are 7 micron tip.
7 micron.
Radius.
And the pressure, they control by us or automatically actually?
You would control it by how you touch down on the probes. I think Ryan, you'll probably probe something, right?
yeah, we're gonna probe.
Yeah, he'll
something,
touch down the probes and he'll show how you should touch down and see the skate, the pattern.
And how the die actually comes, is there a roller for the die?
There's vacuum on the chuck, so if it was a wafer, you could use that.
Oh,
If
the
you-
chuck is porous, really?
Yeah, those are
there's holes
holes
in
in
it.
Oh,
Yeah, we had one on the scope.
I moved it, I'm not gonna lie.
2 of them that you showed on.
Oh, wow, that's not big enough.
Oh, there's one of them. They're pretty small. You get right in there, you can see them.
And how far from
No, there's holes throughout the chapter. So there's different vacuum rings depending on what you're testing. If you're like a single, yes, yes. It's gonna get that. A lot of good questions coming. Okay, all right. Another stuff.
My name in total.
How many probes? 8 works, 8 DC, 4 RF. 8 DC. So, or you can do a combination of 4 RF and 4 DC.
The maximum is
This was a probe will be different for DC probes.
I'm sorry?
Will the arm be different for DC probes?
Yeah, I've got 2 of them actually right here. Completely different. Yeah. All right, shall we continue on? Oh, you have a question? Yes, it is. Yep.
I see one.
There's 3 on there actually. There's one shaft coming down, but there's actually three probe tips on there.
So it's not.
They're very small. It's a 100 micron pitch. Yeah, extremely small.
Okay, that's oh, I see. And then the ones. Okay.
All right. Well, if I can bring everybody back again. All right. Good question.
Okay.
Okay, so I was talking about the Pro Platinum, and we talked about RF position or RF probes a little bit. There's also some DC probes. Mainly, the biggest difference is the arm itself. I'm going to put those on at the end when we do some actual probing. So I'll have you guys do a little bit of that. But the main function of the Platinum is, if you have, for example, 4, 5, 6 or so of these positioners, it makes absolutely no sense to go around and put one probe down at a time. You know, it's a big time waster, and lift them up and move your sample around the next site and then move them all down again. With a Pro Platinum, there's a lever on the side here that you can move them all. Once you have them all at the correct height and all at the same height, you can then move them down and you can have them contact your substrate all at the same time once you have that height set on. And then you can very easily lift your probes up. I don't know if you guys can see that in the back, but this is moving up and down just a little bit. And particularly if you're testing a wafer, you got a number of sites, you can very quickly go over to the next site, and then you can bring your probes back down again. So it's just an easy way to move your probes up and then back down again. So this is what we call, it's a fine adjustment. There's also a coarse adjustment. On the back left of the bridge here, it's a knob that will allow you to move this probe Platinum up and down. This lever will move from the bottom all the way to the top is 3 millimeters. There's also a lock at the top. If you rotate it 90 degrees clockwise, it'll lock this lever in place so you can't accidentally lower it, or if you lean on this or accidentally hit the lever, it's not going to bring your probes down. Turn it back 90 degrees counterclockwise, and you move it down, and there's an intermittent stop before you get to the bottom that's 300 microns off your substrate. And then if you want to go down to the final position, you just touch it and allow it to fall. You don't need to drive it down or bring it all the way down. There's a little detent here. Just overcome the detent and let it fall down. It's a very gentle, controlled dropping of the probes. So, and it's very, very repeatable within a micron. And I demonstrated that to a couple of the gentlemen this morning. You can drop this 5, 6, 7 times. It's going to be 1 micron, less than 1 micron every single time. So really, really good. Okay. The total range of the Platinum, 20 millimeters. So you have a 20 millimeters adjustment. This from top to bottom will be 3 millimeters. Then the coarse knob back here will allow you to run, you know, in a range of 20 millimeters. So just to give you an idea. That could come in handy if you have very, very thick substrates for some reason. The positioners are adjustable also in X, Y, and Z. You'll get 10 millimeters as well out of the positioner Z, but if for some reason you need more, the Platinum will give you more of this knob in the back. The core knob in the back will give you even more height. Okay. Any questions on the microscope, camera, Platinum, before I move on to the chuck?
If you want to do temperature testing, how to seal the whole probe station?
You buy something like that and you put a thermometer on it.
Good.
So you do not have
No, not for that. I don't know, can we do hot
In a dark box?
with this guy?
Yeah, you could do ambient to hot.
You do hot, you can't do cold, obviously, frost up and stuff.
how about the temperature tolerance for this probe station?
Temperature tolerance for thermal chuck, it would depend on the chuck itself.
Okay.
As far as how well it controls the temperature, you mean? Or the range?
On the chamber, control the temperature.
There's no control here.
It's very tough to, I just wouldn't recommend that station for temperature. You bought this station, you should use this station because it's made for that. So I wouldn't attempt it over there. You could get a big dark room, but then you got to heat up that whole mass, right? In
That's
order
quite
to
difficult.
do it. Yeah. Whereas this one is a very small, compact area in there, so it's a lot easier to control the temperature.
Yeah, control the environment for sure. You can purge that one too, if you want to purge it with nitrogen. If we've got oxygen sensitive devices as well.
So that one also a probe station.
Yes, yep. They're nearly the same. Well, that one is a little bit bigger. This one's 150 millimeter, that's 200 millimeter. But the main thing with that one is an enclosed chamber. It's primarily for EMI shielding, but you can also do temperature testing with it as well. So it isolates everything. All right. If I keep going down a little bit further, you have the chuck stage. The chuck stage is also controllable in X, Y, Z, and theta. The main control is this puck here. On the left of the puck, there's a push button that activates the air bearing, and this surface here, all out here is an air bearing surface. When I press the button on the left of the puck, it'll allow me to just float the stage around wherever I need to go, very, very quickly. Very important just to keep this surface clean from dust or grit or anything like that. If you get a little dirt on it, or anything, but it may affect how smoothly it runs. It may not run quite as smoothly. Clean it periodically. When you do clean it, 100% alcohol, 100% IPA. That's it, lint-free wipes. Do not use water, glass cleaner, solvents, anything that would leave like a residue. 100% IPA will not leave any kind of residue. So very, very important.
And once we don't use it, we can use the dust cover.
And you've got the dust cover. I've got that's
Yeah, we have
microscope. Yeah, it's sitting around here. There's a dust cover for the whole station. Yeah, exactly. So the puck you use for coarse movement. There's also micrometers for fine positioning in the X stage here. And then for the Y on the left side of the stage. Again, fine positioning. So again, you can zoom in and you can very, very precisely control your stage movements. And we can see that when we land some probes as well. There's no Z control. There's no up and down of the chuck. I think I might have said Z in the beginning, talking about the chuck, but there is no Z control on the chuck. All the Z is done with a platen lift and your positioners. The last one is the theta. So if you're testing wafers and you want to align your wafer, you have theta control as well. I don't know if everybody heard, but we had a little discussion about Chuck vacuum, vacuum hose. That noise you heard there is the compressor. Haven't got to that point yet, but there's a compressor down there, and as soon as it gets up to pressure, it'll kick off. Okay. So using the stage, it bleeds off a little bit of air. So the compressor is set at 60 psi. Should always be at 60 psi. It can drift down a little bit, not a big deal. You get below 40 psi. You don't want to go that low, and don't want to go above 60 psi. Also, there's a regulator directly on the compressor, and it's adjusted right now for 60 psi, and you can leave it right there. There's also a small tank, so slowly the air will bleed off. It'll leak out in places, and then if you're using it a lot, you'll hear that cycle more. If you're not using it at all, you'll hear it cycle maybe every half hour or so. It'll just run for 30 seconds or so, and just charge up again. And next to that is the vacuum pump, and I'm going to turn that on in just a little bit as well. Nothing to do with the vacuum pump other than the power switch on and off. All right. Vacuum holes. There's a switch on the side here for chuck vac on. If I turn that on, there, I don't know if I can see them all. Basically, I'm looking for 4 vacuum holes in the center. So when you put the switch in the on position, it'll activate 4 vacuum holes in the center. So if you're doing a single sample or a small single die, best place to do it is right there in the middle. You turn your vacuum switch on, and you've got vacuum just in those center holes. You guys aren't going to be able to see this, but on the left side of the chuck, there's a switch for the vacuum, and on the switch we have C, 2, 4, and 6. So what that means, C is all the way towards the front. That means just those 4 center holes are going to be active with vacuum. If I expose the 2 on the switch, then you can use a 2-inch wafer, and there's a ring just under 2 inches around the center that will activate when this is on 2. If I go to 4, likewise with 4, if you're using a 4-inch wafer, the vacuum rings will open up to just under 4 inches. And then lastly, 6, which would be all the way in the back, would activate all the vacuum holes on the chuck.
So the minimum size of the die, if they go is just this full, this the holes.
Yeah, it's hard to use something smaller than that. You could try to just get it on a hole, or what I've seen other customers do is they'll have a smaller, like a blank substrate, and put the small die on that. Mount it on with some, I don't know, blue tape, or maybe a little bit of glue or something on a larger substrate that you can back it down properly.
So the larger should be same size of the wafer, or it can be smaller. So that's it.
It can be smaller. Yeah.
What is that size?
So that size of those 4 holes.
That was your question.
Exactly. So it should be the same size, or maybe a little more in order to show
more
the
than
ceiling.
Right, yeah.
It should be
It's very, I don't have an exact, I would say,
Can you see it? Can you
yeah.
Oh, it's tiny. It's like 5 millimeters by 5 millimeters.
Yeah.
I think we may clear this one because I'm not sure these particles are there. It can actually
Right.
suction.
Well, the chuck surface, yeah, it should be cut clean also. Yeah, and the chuck surface also with 100% alcohol as well. With pre-wipes. Clean that surface periodically.
Right. We have instruction manuals for this machine, right? which includes,
There's a user guide, there's a
Yes.
soft copy of a user guide, I'll make sure you have that,
okay,
absolutely.
because in that there should be a discussion for every tiny things.
Yeah, all the adjustments, everything that we talked about, yeah, it's right in the user guide. I'll make sure you get that if you don't
Yeah.
have that already.
I'm taking a note, Brian.
Oh, okay, all right, perfect. And also there's a user guide for the TS200 as well. Okay. Lastly on the chuck, in the back right, I don't know if you can see back there or not. Oh, let me get this one out of the way. There are two ceramic blocks in the back right of the chuck. Very important for RF probing or high frequency probing if you have a calibration substrate or even a probe cleaning substrate. Basically, it's a small die. You can load those independent from the main chuck. These are ceramic, so they're designed for electrical insulation. They're not going to get any grounding or any noise or any kind of influence like that from the chuck itself or from the aux chuck itself. There are in the back right corner of each of these ceramic aux chucks, there's what we call a fence. So the idea of the fence, I don't know, looks like that. I don't know if this is doing it right, but you want to take your substrate and bank it up against this fence. So you place your die, your calibration substrate down flat on the ceramic, and then push it into the corner where these fences are. I don't know if that makes sense if I describe that very well, but hopefully it does. And when you have it in proper position, you have an aux right vacuum switch and then an aux left vacuum switch to turn those on. And once you have it loaded and you have the vacuum switch on, then you can just nudge it with your tweezers or whatever you use to load, and it should fix it firmly. Make sure you have good contact. These are also very important to keep those clean. Keep the back of your substrates clean, and keep the surfaces of the aux chuck clean as well. Very, very important for vacuum.
So can you
Good
use the
vacuum
regular,
hold.
the regular wipes, right, with the IPA?
Yeah, ideally lint-free wipes or clean room wipes, and 100% IPA. Exactly. Where are those things that you said? They're here. It's the metal on the side. They only stick up about 200 to 300 microns above the surface. You can see them on the side, but it's just barely above the surface. We need to keep those fences below the thickness of any substrate you put on there, so there's no chance to run your probes accidentally into the fences. So you have to keep those fences very, very low. Yeah, exactly. So just enough to catch your substrate when you put it on. Okay. The last thing, there is a knob. This is a vibration isolation platform here. Not sure if you will need it or not. You may on upper floors. And I don't know if you have trains or trucks going by frequently or anything like that. They can affect it.
Maybe the TTC.
Pardon?
Maybe the TTC runs close enough.
Yeah.
Guys, yeah, get a little bit of rumbling and stuff.
We'll have to find
Well,
out.
yeah,
Let's
it's
see
here,
what
it's
happens.
actually here. It's something actually running all the way down.
One of the stations is right.
Yeah, Black Creek is, yeah, Black Creek is on.
You may see it, particularly on an elevated floor when you're on the upper floors. You can turn the switch on or open. There's an open and close. What that'll do is it'll bleed air, and this platform will start to float. Give it about a minute or so to come up. And it's also important to have it on a good level table as well. I didn't check the level on this one, kind of eyeballed it out, looks like it's pretty good, but you don't want it like at a gross angle. It'll work very well for sure. So if you see any instances of vibration, and you would see that on your chuck, and even with this zoomed in, I didn't notice anything of vibration. But if you do have a train coming by or something like that, you start seeing
Jump up and down.
things like this. I don't want to make the people downstairs mad. So, well, let me see. That's pretty much it. If I missed anything or not, Does anybody have any questions? Actually, before that, let's talk about the pumps down below real quick. On the left side is a vacuum pump. Turn that on. The vacuum pump is not like the compressor. It's not going to cycle. It's just going to turn on. It's going to run all the time. So you may want to turn it off depending on, I don't know how noisy it's going to get in the lab here. But in a quiet lab, it may or may not annoy people. We'll see what happens. If you need to turn it off, power switch, we're off. On the compressor, because it's already up to pressure, I'm going to turn it off, but it's not going to do anything. There's a rocker switch on the very top, and just an on-off for that. Both of these are plugged in right here on this power strip. And then the vacuum and air lines come into the back of the station. There's two inputs, one for the air and then one for the vacuum. Nothing you need to do with these. You may notice, the only thing I've seen is sometimes these can walk a little bit around over time. So running all day, they may want to wander a little bit. If they do, if you have a rubber mat or something like that, a small rubber mat, you can put on a rubber mat. So that'll minimize the walking around. Now, do you have any questions or anything?
You can place the lever like that for whatever we need, the black lever that we use.
This one?
Yeah, we can unlock to repositions, different positions. Right?
Lock to different positions.
Like we can take it out and put it place.
Can you show me
One
what you mean?
also use the unlocks, right? Or
Yes. Yeah, and actually, you kind of bring up something that I was remiss in my instruction here. There are bars on top of the platen here. These are designed as alignment bars. So for my east-west positioner, there's a bar here. And the base, that magnetic base, positioner should move right up against that bar. And that'll allow you to move in and out and stay aligned. It's a little tricky on the platform. And then in the south positioner, same thing. You want to bank your base up against the bar before you lock it down. And the reasoning for that, or what I'm told, is it's very, RF Pro is just very, very sensitive, very, very touchy, and everything wants to be, everything in the line, and the probes all planar, all hitting at the same time. You don't want the probe kind of off at an angle, or anything like that. These bars are designed to keep the probes in a precise angle. I don't know if you were getting at that with your question, but maybe think of
you were
that.
discussing about the north-south and
Yeah, exactly. And on that same subject, so there's a obvious difference. I passed around what was a north-south arm. It's got a 90-degree right angle to it. And the east-west arms are just a straight-in arm. There's no bend to it. Functions the same way. There's no bend to it. Now, the other two positions on the other side, they have the same bars that you can bank them up against.
Can we also move that tip, like this one? This one? Moving like the up, down, or
Yes.
side?
So
Or using this.
that's this guy. Yeah, you'll get 10 millimeters, X, Y, and Z movement. Yes, exactly. One trick that I like to tell customers too, when you're setting things up, particularly if you do it like if you use all 4 positioners, it gets very busy. There's a lot going on in there. Start with the positioners with the X, Y, and Z axes all in the center position, the center of their travel. You don't want any axis like completely to one side. very, very important, because once you're setting up, the worst thing that can happen is you almost get there and you run out of travel in your positioners. So you can line up the X, Y, and Z. If all these blocks here, this stack of blocks is all right in a row, that means your X and Y are going to be lined up. And then for the Z, there's a block here for your Z bearing. This one's a little bit more difficult to see, but you want these blocks lined up as well. That'll have your X, Y, and Z. So before you start putting everything in, just make sure these are all centered. It'll save you time and basically time in the long run. So particularly when you get close to the end of the day, you're trying to do something really quick. Can be a little bit of a pain in the butt if you run out of travel. Any more questions? Did that answer your question? Yes.
I have a question for you. You might have already talked about this. Like when you're trying to adjust in the X and Y directions, you actually have visual vision through the camera or so on. But for Z-axis, how would you be able to adjust your height and so on?
Great question. With a chuck, you can. You cannot. So at least for your substrate or your device, there's going to be no Z travel whatsoever. So everything is done with your probes, either with a positioner Z here, or your coarse platen adjust here.
Because it's really difficult to make sure all of them have the same position with the Z-axis, and you might damage the probe or actually the substrate and so on.
Takes time, yeah, for sure, and you want to go slow, and it's very tricky. Once you get used to it, it becomes easier, but when you're first learning, yeah, it's treacherous. You know, it's very, very difficult. You can see it, and then after you do it a few times, it becomes almost second nature. When you're first starting out, it's kind of hard to see when they're coming into focus and when they actually touch down. It's a little bit more obvious when they touch down. You can see on the screen. I'll show you that. But yeah, real dangerous for sure when you first start out. I'll tell customers, it's like, if you haven't used a station like this or you're new to it, these DC needle probes, super cheap. You know, I mean, Ty will sell you a bunch of them for sure. There's nothing to them. If you damage these, it's no big deal. They're great to practice with. Something like that. And just get used to setting down the probe. Get used to the positioner Z. Get used to using the platen and dropping the platen down. And just get comfortable with it. And also use like a piece of junk. Don't use your best device. You know, it's like, it's a new station. Hey, you got something you really want to test? Use something that's been in your desk for a couple of years or whatever that you don't care about. Just play with it.
So you don't tell where you are in Z, but shadows and things out of focus will tell you whether you're close or not. If your substrate
Yeah, I was
is focus,
wondering if they have anything systematic to tell you,
put the substrate in focus, lift the Z tips all the way up, so it's safer. You can see that they clear the substrate, and then there will be out of focus. And you just bring it down as they come in focus, the shadow will get close, and then when you're touching, they, yeah, and then when
That's
they
the
start
only
touching,
feedback you can get, the shadows? There's no way to measure the distance? It depends on your substrate. If it's not reflective, it might be tougher to see,
Yeah,
right?
it's
But,
all the
But
perception.
silicon chips
Stations
reflect
the
it
same way.
but I don't think so.
It's a perception thing. We can
But you're right, what you see is
show
once it
that.
actually touches, it will move, right? It will move or it will get stuck.
It will go
or-
up.
Yeah, you'll see it.
I think Brian will talk about, they call it skate, right, when the seams go back.
Yeah, skate, scrub, there's a couple terms for it.
So Brian, I guess, are you going to, when you show your example, can you talk about the right order to adjust things? Because I think it's pretty important that, your platen should, I'm assuming it's the first thing you adjust because you have the most control over that, and you can travel the most, and then kind of move your way in from there.
Absolutely. Yeah, a couple critical things, yeah, for sure. And even if you don't, this is kind of a weird one. There's a way that I like to do it that works for me. And as you use the station, as you do stuff, you're going to figure out your own way to do it. If it's not 100% exact, it's not a big deal. If you can safely probe stuff, you're not damaging your devices, you're not damaging the probe, if it works for you, more power to you. Absolutely. There's no one set way to do it. If you find a way that works for you, like I say, you don't damage your devices or your probes, then more power to you. Let's start with the easiest. And everybody might do it a little bit different, doesn't mean the other person's wrong.
Could you also explain why that probe arm has that disc towards the end of it?
Yeah, so what that is, this positioner is actually for that station. We're just borrowing it for today, so that's like an EMI cover that's going to interface for that side.
So how many DC probes there are for that station?
25.
What? About 25%?
Oh, no, I think there's 4 probes. I think you asked how many probes, right?
Right.
Oh, probes. There's probe needle. Oh, I'm sorry. Positioners, 2.
There's 2 DC positioners.
2 DC positioners.
Well, there should be 4.
2.
4 each of 4 for this one. How many for?
No, yeah. There should be. There's 4 arms. Yeah, there should be.
Alright. So you mean we have 4 RF for that station, 4 DC for this one?
Now, just
Oh,
right now, I
you
want
mean
to
this
talk
one?
only about
Just
that
for
one for
this
now.
one, yeah.
Because at the very least, I need 3. I can do DC stuff.
Yeah, right.
Oh,
It would be annoying if you also had borrow from this, or like,
Yeah.
you don't wanna like bring
Yeah,
together.
there should be 4 per station.
So that means we have 4 DC and 4 RF per station?
4 DC should be for this one. Position.
So we have-
Draw a blank.
16 total?
What?
16 arms.
4 and 4.
So
Positions, or 8 positions.
All for both stations.
Okay, and then how many DC probe arms?
Plus in the action.
Yeah,
man.
4.
Okay, 4 in total, so 4, okay.
Yeah. 4 probes.
Okay, and 8 this. 8 measurements.
Yeah.
Okay. So basically, we want to do DC measurement, we can't do DC measurements on both stations at the same time, right? If you need 4 probes.
Yeah.
Okay.
Okay, I'm going to talk about what I just did, loading the needle. After you guys get done playing with this one, and I get that one set up, I'll show you how to load the needle. For the moment, I'll show you how to set a probe needle down, and I'm just going to use the chuck surface. A couple key points with probing. You want to be very careful when you first put your positioner with your needle over your chuck or your substrate. Not a bad idea to Z up your Z axis on your positioner. And on the positioner, there's a nice little Z up symbol. It'll tell you which way the Zing up. It's a reverse thread, so keep that in mind if you look into this real close. Up is not what you might think it is, so you always look at the label on the Z axis. It'll tell you which way it is up. And Z up. Your positioner. Make sure you have good clearance over your chuck. Very important to have the platen handle down at this point. You do not want to have the platen handle up, you want to have the platen handle down. And also, if you're doing multiple needles, which is usually the case, try to bring them into the central position on the chuck. You only have so much room or movement with the microscope, and even less with that one. So if your probes are too far off center, you could get out of the range of your microscope. And again, making your life a little bit difficult, having to recenter everything. So when you first bring stuff in, try to bring up eyeball it out as much in the center as possible. So right now I have the needle itself well above the chuck surface. I have the platen handle down. And next thing I'm going to do is I'm going to see if I can't find my probe needle. I'm going to zoom my microscope all the way out. Still can't see it. There it is.
Ryan, you want something to prove?
In a minute, yeah. What was that? Well, I think somebody did grab something.
Do we actually have something? We have a sample. Might be just with the probe, but we have one.
Okay.
So I
Yeah,
got-
in a
I got
little
business
bit.
cards, so,
Because I'm going to have somebody else put the
they're
next
awesome
one
for
on.
probing.
Okay, I'm going to have a volunteer put the next one on. Oh, fun. Good. We can start on here. All right, wonderful. Thank you. Okay. Once I have the probe needle in my view, I'm going to slowly get an idea just by feel of the microscope. That's my chuck surface. That's my probe needle. Close, but not that close. So when my needle is coming close to the surface, the needle should look something like that. It's going to gradually come more and more into focus. And I think you had mentioned about the reflection. Also, you'll start to see a reflection in the shadow of the needle on the chuck surface as well. That'll help you out. Check that focus. Moving the needle down. Positioner Z. And if you're not sure, start seeing a shadow of the needle right here. If you're not completely sure, it doesn't hurt to just go back and, okay, there it is. Just double check where you're at. We'll try to get to the chuck surface. The shadow is going to become sharper. And the needle's also going to become sharper. Zoom in a little bit more.
Where's the handle right now? Up position or down?
The platen handle's down right now. Whenever you land your probes on something, it's absolutely important to have this platen handle down. Can't emphasize that enough. Save you a lot of heartache. And when the shadow and the needle kind of come together as one, what you'll see when it touches, you'll see the needle is going to start to move forward a little bit when it makes contact. More even.
So how much you want to go further after the contact?
So that's contact right there. If you guys can see that back there. There's the light on this sort of works. I mean, it's a digital camera, it's adjusting. So I drop down, you'll see that the needle move up a little bit. So that's the probe needle touching the surface. And depending on what you have for pads, aluminum or gold, some need more skate or more scrub than others. What I see some customers do is for their particular test, they'll turn on their measurement equipment and they'll just slowly bring them down until they get a good measurement, and then they know that they have enough scrub. They know when they have enough probe pressure on there. If you just touch them, sometimes you don't make a good contact, it needs a little bit more. How much, it really depends on the device, the pad, the probe. So that's what we call contact, and then you do the same thing with the next needle. Next probe needle, have somebody do the next one. Get a volunteer up here, but just to demonstrate
So when you have
platen function as well. I'm just gonna do.
when you have multiple probes, you do then now, even though this probe is touching the surface, is it okay to move the chuck around while you have to adjust the second one, next one?
No, you're gonna, it's a great point. If you try to move the chuck, either with the micrometers or the puck, you're gonna destroy your probes.
So how do you, when you have more than one probe, how do you do this step?
So, if you got more than one probe, it's very similar in what you do. Having your X and Y and the Z in the center, you start there, start well above your surface. And the first thing you want to do is take all your probes and move them into the field of view. You zoom out, and then you get all your probes, 3, 4, or 5, all within the view of the camera. It takes a little bit longer. Take your time. Don't try to rush through it or do it quick. It's too easy to make a mistake. But what you'll do is bring them into the view, and you'll gradually be dropping them down, bringing them closer, dropping them down, and bringing them closer. Basically repeating this process that I just did for all probes until you have all 4, 5, 6 probes touching the surface at the same time. It's very, very important once they're down to not touch anything, the chuck, the micrometers here. If you do have to move, pick up the patent handle to the D10, that'll give you 300 microns off the surface. And then I want to move just a little bit here, and then you can just drop it down again.
And then lock it, then you vacuum lock it at the end?
You can't lock it at the bottom. You can lock it at the top, but not at the bottom. You mean this lift?
No, there was a vacuum switch which apparently locks the chuck, does it not?
The button on the left side of the chuck will activate the air for the air bearing, and when you release it, it will apply vacuum, so this will be locked. And then there's the vacuum for your substrate for your chuck vacuum. It'll lock your sample down to the surface. Did that answer your question?
But in case if accidentally it moves, like not move,
Don't do that, yeah. I mean, yeah, if it does accidentally, if you've got your probe down and you accidentally move something, hit something, then
Don't bump into the arms.
yeah.
So can that chuck be biased? Is it instead isolated? Is it grounded? What is it?
Yes, you can. Good question. So on the back, left of the chuck, there's a coax BNC connector. So yeah, you can plug anything, either bias up to, I'm not sure about 50 volts, 40 volts. We can bias it, but there's a limit. Yeah.
Okay.
For sure. And then you could short that connection, grounding it, if you want to do that as well. Right now, it's set up, it's just open.
So to interpret that the center pin of the coax with respect to ground is a connection between the ground and the chuck,
The center conductor is connected directly to chuck surface.
and the other shield is proper ground.
Yeah, that's gonna be your instrument ground, whatever your instrument ground is for the shielding of the coax. Yep. Alright, so
Which one is for this simple? Which one?
are you volunteering? I know. Which one, sorry?
Just which one for this, which is the five hours.
So the main difference is the probe arm. And because I'm touching in here, I'm just gonna lift up my probe needle just to be safe and lock it. So this guy, this is the most obvious difference.
So this is
This is for the RF.
This is for
RF. And we have the screw mounts, and then the DC is just that single needle holder. Yeah, exactly.
What's explaining the RF arm?
Right on there, and then there's a connector. Yeah, it's pretty cool.
They're less than 1,000.
Do some repairs.
Yeah, some will change in terms of the size. At least you guys pay like millimeter wave markers, like that stuff is really expensive. Yeah, these ones you buy. These ones you can leave these ones out. It's in that area right where it's sort of getting spicy, but it's still it's not like tens of thousands. Like some of the 100 gig ones are like yeah, I wouldn't use these ones. You guys ever broke something?
I forgot to mention, the mounts for the RF probes, there's 2 screws for mounting the probes. The positioners come with a nice little feature, it's a magnet here to keep you from losing the screws. So there's a little magnet on the corner so you can put your screws right there.
Sounds silly, but it's very handy.
Yeah, it's really, it's just little things like that for sure. Does anybody want to come up and touch and feel and play around with it a little bit?
We have more DC Pros, similar to
Yep. I don't know if anybody wants to touch and see. Oh. Yeah, sure. Absolutely. Yeah.
Maybe I can really know in some cases.
Oh, yeah, did you find it?
At least you can like it's more from the practical aspect, but you can grasp the magnification because you can see that's the G or like where we get our chance. They can actually show the back of how it works.
What? Seriously?
Yeah. Alright, so like at least yes. Yep. So it doesn't turn out to be a little bit of it's actually
So this one you have the second. This one you have
no, I'm going to send this one back. Yeah, exactly. When you guys are playing with that, we're going to put the other needle on it, the lights is on it, stuff. And then once you guys are ready, oh, this one doesn't need to work.
feel confident that they get it. That's the chain. Yeah. Oh, we can
one more just try out. Yeah. We're going to do some trial and
It's all.
Somebody want to volunteer?
Which one? Rather than wreck a business card.
So right now this is new, right? So this was just like product. Same thing as like a sheet.
Yeah, so everything is isolated. EMI,
Same flow control as
They're not different sizes. Guys, after I come around, we're just gonna put one of the DC needles on the profile here. It might be interesting to see.
you have to limit it, right? Because there were, you know, two foods. The next one is
Yeah, it's tricky. I'm gonna show you. I'm actually gonna have to volunteer. You wanna do it? So, in this probe arm, Triax probe arm, there is a tightening column here, and there's a split where you push the needle in on the front, and at the top of that split, there's two holes. One closer to the front and one closer to the back. And then at the bottom, there's just one hole. So both these holes can go out of the same exit hole in the bottom. It just gives you two different angles. There's actually a groove cut in between, so it better grabs the shaft. So. So, dip is on that side. Yep. And you want to push this side right to the front. And then you can push it right through from the front. And then we'll go in. And the hardest part is trying to feel where those grooves are. It's always a good idea to hold on to the needle until you have the collar tightened down. You gotta kind of move it around. Once it drops in, you'll notice it. And the hole in the bottom is almost right in the very front. One angle is 45 and the other one is 45. When it goes in, it will operate. Do you want to check?
I need to move everything there. So, can you
There's a lot of play in it. Oh, when you do find it, it all of a sudden becomes really loose.
Yeah.
Okay, so I should take it all the time?
Yeah, right there. It's just really, really loose. When it's like this, it tightens up. You might be able to feel it better with your fingers. I don't know.
And my problem is when it's on the second one, I couldn't find anything that it's just here. Now I can.
Oh, now it's on. I think you got it.
Yeah.
Yes, yeah, you got it. Okay. All right. And when you think you've got it, you can go ahead and just tighten up that collar. And you can tighten this up pretty good. and then it'll pinch it.
So that it doesn't move.
Yep, exactly. And then that's it. But the hardest thing, yeah, is just finding that groove. It takes a little getting it. When you find it, then it gets really loose, and you'll know it. And then after you do it half a dozen times, you become an expert really, really quick.
So the RF probe is, you were showing in the box there, right? That's the RF probe there? So where does this fit?
No, this is a DC one.
So this is not
It's
going
a
to be.
DC, it's for a different arm. Yeah.
I see. So it's going to be.
Just like basic.
I see.
I see.
Maybe I just want to make sure they're about the same distance below.
So you're doing this with looking at it?
Approximately,
It's inside.
This is my question, so it's very hard.
approximately, yeah, a little bit.
Yeah.
Just the distance.
Micrometer distance.
So, because the distance from your probe tip
So
to the
there's
probe arm to your
like a
probe tip.
marker on the
No,
on this, so we can put that marker as a.
there's not. And you only get 10 millimeters of travel here. So these got to be at least within 10 millimeters. So try to make, they don't have to be exact, but just try to, if you can, get them as close as possible. Let's get this guy out of here first. All right, so we got the probe needle loaded. So the next thing we should do is probably tilt the microscope back.
Yeah.
If you want to take the microscope and just tilt it to the back position. It should tilt right up. There you go. Yeah.
There's a focus. There's a focus.
Yeah. And then you can take the magnet and turn the magnet off.
The other side. Just slide it.
This side?
Yeah.
Slide it off.
No, this one. Here, you can see.
Like slide. Yeah. Slide on.
And just be careful of the. Oh, the needles are they're cheap, but they do. It's very easy.
Be careful.
And any little pressure, and then you can pick them up.
Very sharp.
And they are sharp too. Yeah, you can potentially injure yourself. And just for fun, let's leave this one off.
Then we can make it with space.
Oh, there you go. Yeah. And then when you put it down, just make sure you clear the chuck surface okay. You should be. Okay.
It's okay?
All right. All right. And
So the distance of this is important. Very good, this is important.
it's important mostly for the RF, not so much for DC, but for the RF, it's important to have it here against the block. For the DC, it's most important just to be centered. That they're all the tips of the needles are in the same position. So that this one is in the same position as that one, or near the same position. So if you can slide it
It'll
around.
work until there's less pressure. Right, so as soon as you hit a certain PSI, it's too
Because
low.
it will be two different legs of the IC. So in this
It's like the
separation, right?
right?
You're probably maybe one leg, two legs.
Because that one's more pushing.
That much close.
So then pretty far away.
Put it close to each other.
A little bit closer, yeah, more towards the center.
So the pump is pushing there. Okay? So that one does the tire where you turn off.
We'll lock that down. And then
that's
we
why
can
you
put the
go here.
microscope back.
Do you want to raise the chuck yet?
Why?
We can't raise the chuck, so go right ahead, sure.
So this one needs to.
The chuck, there's no Z
The
on
air
it.
is what allows you to.
So, the next thing we want to do, getting back to your question, how you make them the same.
Yes.
So we're kind of getting to that
And
point.
then the microscope.
So next thing we'll do is we'll zoom the microscope all the way out, the minimum. Yep. So make it to the least amount of zoom.
Well, it's just so things can move around nicely. It's almost
We're
like
looking for that second needle. I don't think we're quite there.
Yeah.
So we're gonna have to move the microscope.
That's the highest.
All the way out.
I put it
Yeah, the vacuum is what's going to flow
Perfect.
here.
So the scope switch, and at the same time you do this, just hold this
Well, you will
lever
for
here,
eventually.
and this will move the microscope around. Right now there's vacuum
It's like you had
holding this in place. As soon as you turn that off, it's gonna move very, very freely.
It's the same concept.
And then we're just gonna move around and try to find where that other needle is.
You just take it in a different position.
Use like you hear it.
That's
Oh, it's a little bit. Oh, okay.
So
All right.
So-
Pretty good.
so
So, and then when you have it, you can go ahead and lock it down, or
Yeah.
maybe try to move it a little.
Yes,
Try to
now
center it.
it's
Oops.
turn on.
Oh, yep. Perfect. And then you can put the switch back on, and then that'll lock the microscope in place. All right. Yeah, that's this button one here.
So we can close
Yeah.
that.
Oh, what did you do? You broke it. No. So this is where it gets a little bit difficult. First thing we want to do is maybe move them using the X and Y in the positioners. Move these a little bit closer. They're not. That's right. So we're gonna just move them closer on X and Y, and at the same time we're gonna zoom in. Pretty close. So, and we're gonna get them pretty close to each other without hitting each other.
Not that one.
Yeah, both of them.
Oh,
Yeah, both of them.
same thing. That is why. Do some zoom maybe.
Yeah, that's not bad.
That one more expensive than
All right. And also what we want to do is, because we still have our flat handle up, so let's go ahead and just bring the Z up with a little arrow. And we'll bring both of them up a bit, maybe 3 or 4 turns.
Was it automated? Automated workstation.
What's happened?
Yeah, like it moved automatically.
It's going, it's
Do
just
you have any
not.
clue of how
Yeah,
much
that's why it's semi-automatic.
how much the distance changes with a turn?
Oh, UFCS, it's like
Approximation pitch on those. I believe it's 100 microns. It's
Like
100
one
or
full
200
turn would
microns.
be about 100.
Yeah.
Yeah, that's why we're bringing this in.
Bring those up. Yeah. And then maybe bring the other one up also. Yeah, you won't see it, especially on a low mag, you're not going to see the focus on the needle change. So what we'll do is we'll bring the needles up, and then we'll put the flattened arm down. Okay. And we're well on. And when we bring the flattened arm down on the side, we can watch the needles too, just to make sure that they're not going to contact the chuck surface.
What is the purpose of this wire?
For your instrument, not your probe.
The scope one is when it's down.
So I should put it down?
So you can go ahead and put the flat handle down, yep, and watch your needles at the same time, and just make sure that they're not going to hit the chuck.
But it's not going to change this. It's just going to
Oh,
hold this. So it
oh,
doesn't. You'll still be able
we're
to
safe. Okay, but do you want to practice that? Yeah, there's a, if you put it all the way up and then you rotate it 90 degrees clockwise, there's a little lock
So
that
then
pops
the left
out,
and the right
Yeah.
is the auxiliary
and then you
chuck.
turn it
So the two
the other way,
white chucks
and then
in the
it's
back.
free.
You're supposed to be very free.
Yeah, it is. It's very, very free. It's gravity bringing it down. And then there's a detent at 300 microns above the surface
There's no
where it'll stop. And then if you push it a little bit more, just tap it down, it'll go down by itself. Yep, exactly.
And then the chuck is the actual chuck.
All right.
So now we are just
So now, we're similar, but you're gonna have to zoom in. This is where it gets tricky. We're gonna zoom in, and we're gonna focus on the chuck surface. So if we zoom the microscope in quite a bit,
may I ask, what's the goal right now? You want to zoom in so you can see both of the needles?
we're making
Oh, that's
the,
You want to break them?
making the same height.
Yeah, making the same height, but so we actually, can you, let's say in this particular case,
Well, yeah,
you
yeah,
can
I don't know if you
close
noticed
it together, whenever, but if they're not, would you zoom in on one, lower it down, then zoom in on the other? It's like moving the microscope, or would it be
Hard to do.
hard to do?
Hard to do. Let me think about that one.
It'll work.
Yeah.
Yeah, you want.
You have to, I think, calibrate them, all of them, with just one. It's not possible that just one by one.
Ride a bike. You can ride
We
a
have
bike.
to
Really
make
shots.
two or two of them in the same distance, then another one with one of them, another one with one of them.
Far
Yeah, it can be done. I understand.
further than the microscope.
So let's go ahead, yeah, focus on the chuck
So basically
surface.
both the different places. Let's do one by one. Yeah, with one, just moving the microscope.
How we can
Write
change
it down
them.
until you actually want to.
Oh, I'm sorry, this guy right here.
Okay. Yes.
So, and then you just want to keep bringing one of the needles down at this point.
No, I don't know, because.
Slowly drop it down.
If you buy any eyes from it,
And then you start to see it come into focus, and you'll also watch for a shadow in the background too. So you see that I think there's still quite a ways.
Put it down or
Down.
Well, I guess what I'm getting at is if
And
there's not
setting the
far
needle
shot,
heights, this is probably the hardest thing to do. You know, it takes the most time.
People always throw the higher shot because of
As usual, it'll become easier, but it always
yeah,
takes
so I took a note that Brian's
So,
gonna send
see, yeah, start coming in a
also
little bit there.
for the 150 and 160.
Maybe one, maybe not. Oh, yeah, yeah. Start coming in, so you're getting closer, keep coming.
Yeah.
Basically, yeah.
But yeah, we'll for sure
What's
provide you documentation
No, just moving it.
that you know how to use it.
So suppose that
And then when they come together, you'll see that the needle move forward. Might need to focus just a little bit.
yeah,
by sight we can see them now.
No,
They are
oh, right
connected.
there, yeah. No, they're not quite connected, but they're awfully close. They keep coming down, and then you'll see the needle start to
So
move
you'll see
forward.
better when the sun comes off.
Yeah.
And I think it touched. Yep, exactly. And then you can do the same thing with the other needle. See the shadows start to come in. Shadow is good visible now. Of course, it should start to move a little bit. Yeah, right there, perfect. Perfect. So now you know that they're both at the same height.
Now
And then
we
if you had
can
a
change.
third one, yeah, exactly. So now you can do stuff. You can lift the platen up as well. Once we have them both the same height, yeah, we can look at the devices a little bit. In this case, because the probe needles, they're on the chuck, and as soon as you hit that, put that on, obviously that's going to be higher than the chuck surface. What we can do is that knob on the upper left, very gently, this guy right there, you got the Z up, it's got the same arrows on it, and very gently watch the needles, and then they should come up. Yeah. And then just crank that a few times, a bunch of times. We want to get some distance,
So they are at the same.
and they'll stay at the same height, exactly. And then once we have the device on there, we can use the same knob and then bring them back down again. But go ahead and crank them up quite a bit, right, and get them right off the surface.
Do it to the end.
Oh, it's at the end. Oh,
Yeah.
shoot. Okay.
I don't know. I think.
Yeah, I think you are at the end. Okay. So what we did, we basically have to repeat the same procedure, but on the device, unfortunately. That's too
Is
bad.
it possible to bring this a little down?
No, not. So it's done here. We zoom, and as soon as we touch these, then of course they're not going to have the same height anymore. So we have
Because it's
to.
very important. We can make the probes at the same distance from the surface without the device, and then put the device, and now we don't hurt the device. If it's possible that this goes down, it has place to put the device. So
But it doesn't go down, so we're stuck. So what we have to do is repeat the procedure, and we use the positioner Z. So we'll bring those up again, and then we'll proceed. Repeat the same procedure, but with the device in place. I was hoping we'd get more out of the platen. Okay.
So if you help, we can actually place one of these guys, because most of the streamers, they have similar guys actually. Then we can find out, you want to try? Okay, so try to place one of these guys,
okay.
and particularly one of the hole, and let's see how we can drop down actually.
No, my problem is how we can.
No,
I think
so
it's
this
very
one-
small. It's not possible.
Oh, should be.
It's
Maybe to
possible?
be safe, we can lift up the platen handle.
Yeah.
You just, lift up the microscope, and then the platen handle also. We can
This
move the handle. Yeah, and that'll move the probes up even more. Oh, you know what? Because we're on.
That's the sugar in down.
So I'll make a note.
Well, basically, yes. Normally there's a slope design.
Yeah, right at the very upper limit.
Make sure it's not.
Which side should you have? Which side should you have? This is right?
I don't know, because we need to see which one is. I said we could actually
I
use a
think
marker.
that was right.
Yeah,
Yes.
That's your best option, right?
yeah, you can give it a shot, see if it's gonna
Give it
hold.
in there, so maybe we can actually just check the marks.
See with the microscope, yeah.
It should be on one of the holes.
Yeah.
Yeah.
No.
First of all, we need to zoom out. We need to out left and right.
You can either move the chart or the microscope.
I think we should move the microscope
And I would
because
probably move the chart
under
because we already
the
got our
probes
needles
we
here.
don't have any hole.
Oh,
I have to bring it. No, that's.
I think you're on the hole.
Yes, they are on a hole.
There.
So that's a
Why am I driving? Over here? You can drive it. There's a push button here.
one or two.
It'll allow you to move
I
around.
found it.
Oh, there it is. So I think we found a hole for sure. Looks like it's got it. So you can turn the chuck vacuum on. So a couple things. So this will turn on center plus looking down on the side here. So this is the size for the different vacuum rings in the chuck. And all the way to the forward is a C. So that's going to be center. And then a 2-inch, and a 4-inch, and a 6-inch. So you want the C, yeah, all the way forward. So that'll be just these holes.
Oh, that means even if we put it on the C, we can use only one of those. It's not.
No, this four. right?
Yeah, it's going to be those 4 holes. It's going to be the C, yeah. 4 devices. Yeah, it may or may not hold, is all, because you're going to have a vacuum leak. So it's going to hold, but how well it holds, I don't know. You'll know if you put your probes down and it pushes the substrate around, then you know it's just not good enough vacuum. What you can
Maybe
do,
we can test it now to see if it can.
yeah, absolutely. I would probably Z up the probe some more.
We can try to.
Or poke it. Oh, now we're off the hole. Oh, there goes our probe.
It's moving.
Nice moves. Those are pretty tough needles. Oh, we almost had it. Yeah, that's good enough.
That
Okay.
will hold it, right?
It doesn't hold it as well as a wafer. So
Maybe we can put it actually on other holes that they need. Single ones.
Even 2 of them at the same time, I don't think it's possible.
With the vacuum on the
you can
chuck,
try it.
sorry, with the vacuum on the chuck on, if you pull it out all the way, it will still stay on, right? You can just pull it out of the reach of the needles, place your sample out here, right?
Absolutely, yep. Whereas if you got RF probes, if we did that in RF probes, then you can forget about testing for, I don't know, a couple weeks or how long it takes to get more probes. And that's really the more preferred method to do it.
We tried to put it on 2 of them, so
Oh,
a stronger contact.
try it. All right. So the next thing to do is try to put the needles down on there. You have to lower the platen handle and then watch your
So we can
needles.
do it here, for example, not on the device.
Not on the device. I don't think we have enough room.
Because we have also the
The height of the
height
device
of
is
the
more than
device as
this.
well.
Yep, exactly.
The height of the
Exactly.
device should be around
That's why these gotta be.
200 micron. So the limit
Yeah.
was 30.
So 3 millimeters for this one. Then you get 10 millimeters out of this. So there's no problem, but we should start just at a higher position. So we're safe. It's only 200 microns?
Yeah,
Wow.
200, 250.
Okay. Yeah, pretty thin. So, and when you think your needles are safely out, you can go ahead and you put your platen handle down. Because whenever we want to put our probes into contact, we want to make sure that that handle's down for sure.
Put it
Yeah.
down now.
Yep. Exactly.
Completely down.
Completely down. You got it. Okay. All right. So now hopefully we're above. And if you want to find position, there's an X here, and then the Y is right on that side. So you can find position of your device under your probe needles.
This one is trying to put this on the corner.
This one again.
Okay, this one. Oh, this is DC. Both of them are DC. Huh?
Yes.
So we can
Turn these off to position noise.
Yeah, we can use one as a use the other as a guide. For example, this one.
This is good.
Yeah. How we can make sure it's connected now? We need to
That
test
part I
it.
can't help you with.
Test
Yeah.
it, yeah, the only way.
Test,
We
yeah.
can put the DC and ground, and then we see if the current actually goes.
Sure, absolutely. Yeah, yeah.
So if you know which one should
You have a meter, it
The
just should
second
be
one
showing.
should be this one.
this one.
Lots of triangles. Yeah, put a meter on it, even an ohm meter, yeah. So you get any kind of current.
Yeah, oh, that's correct. Good as actually the X and Y is good. I don't know what to do.
The height we don't know.
See, you can,
No.
you can zoom in a little bit. You can see, yeah,
Didn't touch.
maybe one needle at a time.
Yeah.
Because
What's the resolution of this camera?
Six megapixels? Six or 10.
Oh, that's so. You know, the trick probably is when we focus on the pads and we bring actually down the needles, it should be focused because the contact should have the focus, correct?
Device should be focused. Like we focus on a check, the device should be
It should
focused.
the device. So we should. Okay.
Yeah.
So let's put this in the center of the pads, but now it's not in the center.
Center
The
of
tip
the
of
pan.
the tip of the probe is not
I
in the
think
center.
it is.
It's just above it, yeah.
Oh, it's not.
The tip is this.
But the tip is now here. If you put it here.
Yeah.
here,
It's just a bit of
Oh,
round,
good.
yeah.
Now let's have a focus on the pads.
On the pan.
Yeah. No, focus. Only just.
So focus on the pan.
Now we have to.
Focus on the pad like we did on the chuck, and then you bring your needle down on the pad.
Yes, and then we can actually.
So that looks pretty good.
I should
Tricky.
Now let's bring down the needle.
And then bring down the needle on it, yeah.
Is it
I
down?
am bringing
Oh, that's good,
down
that's
the
good.
needle.
So there should
Okay,
be
a
some
little bit
shadow,
more.
right?
No.
Yes.
But we need
You'll
to-
see the shadow again.
Okay, again we need to bring it. No, a little more.
We're close to the top.
Now
of
it's
it.
good.
We're very close.
No, you should stay here because you're looking at.
My device to start around the middle, as you said.
So it should be in the
Yeah,
middle, I
no,
think.
you're absolutely right.
Okay,
I
that's
think we
fine.
don't see the tip is here right now.
But the tip should be in the center of the pad.
Center of the pad, yeah.
Center.
In the middle.
No, but you need to, yeah, the
Close.
focus should be on the device, not on the.
She's
Once
got
it comes
she's got
closer,
it.
you can adjust before touching, right?
Yep. Yes, you got it. Start coming to focus.
Touching the shadow, when it's touching the shadow, right?
When it's nearly touched.
Nearly touching, yes.
When the nearly touch, should
Then
both
with the
of them should
center.
have the focus.
Yes. But I didn't see the shadow.
Then it's 6 more weeks of winter.
What to go?
You usually do, unless you have,
Yeah,
Oh,
that's-
no, it's
yeah,
Yeah, now
unless you
can
have
tell.
something that's like really
Oh.
dark. If you have like a very dark
So now
subject,
maybe we can
some
be
of
in
those dark,
the
it might
center
be
of the
hard.
bed, maybe. Yeah.
But anyway, I think the
Take your time.
only electrical actually test me, so we can just apply the voltage and see if the fan goes through.
Yeah.
That's the only issue.
Some good.
And touchdown,
Touch
yeah.
where to see the card?
Did the device move?
Yes, I think it's not.
Has not touched?
It's touched now, and it moved the device. So it's
Signal to the bed.
Okay, movement, another sign of the top.
So it's not, yeah, touch, and then it's not very good vacuum, it sounds like,
yes, we
yeah.
have to put it on.
It's gonna be tricky. You can probably still test them, but it's gonna be tricky.
Question, we cannot increase the
And the white dot
negative
there,
pressures of the vacuum?
they are pins.
It's the size of the hole. It's a pretty good
Because the
vacuum.
hole, because the hole is very small, and it's really very strong vacuum in order to keep it actually.
With just one hole, exactly.
Yeah, hole is very small, and
It's better to have a holder or something like this, where you could put it on, where you could suck something larger down on.
Sorry for interrupting, but here's an idea. You can just cover the other two holes with something else just to keep the pressure. Have your
But
assembly-
exactly what I said.
So instead of trying to cover everything with one piece or using like a substrate for the substrate, just take another piece and cover the other two holes, just to preserve the
It's
bias.
difficult, you know why? Because the distance between them are very small. We should make the bars at the size of the few millimeters. Few millimeters.
Do what the other just
try it.
put your business card just so the other two are covered. If your device is so tiny, you can have enough clearance for the microscope.
So I think
If
if we
you
give
want-
it on another space and surface,
Another
like
substrate.
gluing it, I think it's.
For example, this can be on the
Easiest way.
size of this one, and then that you can.
It's easier to handle too, yeah.
And by the way, if the substrate where we can actually hold that, it's from a rubber or plastic, it will be much easier. Because it's vacuum and
There's more
attached to the
holes.
surface.
The more holes you have, the better.
Or maybe it's better to see on the
We'll get a
wafer.
fair share.
There's something, some kind of carrier or something like this. The more holes you have, the better off. And you can cover those, but you're still going to have just those two holes holding it. It may not. Depends how much pressure you need to put on your probes. Yeah, slow down. So and also the back side of your device, make sure that that's good and clean as well. Yeah.
Did it actually go?
Yeah, two holes.
Two holes?
Yeah, but pushing it around.
Yeah, that's a good one.
It might have a little dirt on the back too and stuff.
Yes.
What is the main difference
As I mean, it's
in the
rubbish.
operation of these between this and that? Because I think most of us will want to use the other one. And you said
So,
you might
let's
want to
take
cover
a
the
photo.
differences.
Yep.
So planning to do that?
I'm still planning to do that, yeah, I'm getting ready to get that one set up right now. But most of the functionality is really the same.
Okay.
You know, all the operational stuff, but I gotta get on that one and start getting it set up. So I think you guys are about ready to just fly on your own and play around a little bit. You wanna supervise, Ty?
Sure.
Do that?
All right, go to it.
All right.
Oh.
Yeah, and they can just submit that on.
Alright, Ibrahim, what are you trying to? Is it actually staying, or it moves? It's moving around a little bit, right? Even though it's on the holes. Needs more vacuum power.
It requires more power, yeah. So we cannot rotate, you know?
Yeah, you can.
Which one's rotation?
This one,
Oh, this one.
It's not a lot of range.
But yeah, you won't get. That's not gonna probably rotate it that much. But
It's
you might,
fine tune.
yeah, I don't know. You might as well twist it all the way and see how far it goes.
Sorry.
Yeah, you definitely want to use your tweezers.
Good. How to take
It moved.
Take a photo.
Yeah.
You got secure digital cards. There's actually there's a screen capture built into it. Oh, you actually want to take a picture of this?
This is of this one.
How do you put?
Do you want to
how do you
rotate it
stick
more or
this
no?
to another server?
No, I can
Because
do that.
we have some. We may have different like.
It's like just fits, eh?
board or anything.
I think a small personality.
You're tired, we're filming.
Oh, sorry.
Oh.
I see holders.
That's good to be.
We're filming you.
So the only way to really take a screen capture, take a picture with your phone, you might have to take a picture.
Yeah.
It seems so crude to take a picture with my phone. Well, you guys are just taking a picture with your phone. It's no better.
I don't know if you can use.
I don't think there's because there is you have a secure digital card.
I know, but the access, we need the USB for this one, yeah? It's similar to the, a similar camera that we have in that.
If you want, look, you can do here. You can come down to here, and you can actually record, and you can take a picture. So if you have a mouse attached, you just bring this down, and you can actually
For that one, yes.
you can actually control it from here.
For this one.
So you can actually take a picture. I don't think it'll know it's the SD card. But if you have an SD card, you can take a picture. That's
SD card, we don't have this card.
I don't think it doesn't come with an SD card. No, so it does not come with one.
But we have purchased SD card for this camera?
Is the zoom the digital zoom?
Micro SD card.
It's very similar to the
Well,
cameras we have in
On the top thing.
We can buy it.
But on the obviously this is changing.
Because we have already actually identified another device for that.
We are discussing the pointers. The pointers, it doesn't won't find like precisely. Because I was trying with this
I
one.
think taking a picture is your best bet.
Beside, it brings out the one.
It's like it's so old school, right? Having to take a picture with the.
Manually would be. But there is accessory small laser pointer. When it hits the pointer, it will bring it. Yes.
What is this device?
See your photography skills.
For this sheet, every kind of amplifiers. It's nice.
That's what you want.
Sideways.
Yeah, exactly. So this is for the fancy side function. It's the electronics are the microfluidic to the attractive display.
Really?
So these are the sensors for the
Sensors.
So where's that gonna be? Inside the body?
This is for the in vitro, but the goal is actually that it's also in vitro. Okay, this is actually
Yeah, sure. Is the pneumatic stabilization for the whole thing?
Yes. So this platform here is what's stabilizing the whole.
So these things are fixed together.
Yes, that's perfect.
Yeah, it will be actually from the mouth and that can help actually.
We have chucks for active probes.
Chucks for active.
Sorry, micromanipulators for active probes. Micromanipulators for active probes.
For active probes.
Define active probe. These are passive probes.
Yeah.
Just mirrors, right?
Yeah.
Active probes have some symmetrical box on it, so that you put some special tips other than the ones that those are for really sensitive circuitry and high frequency circuits that shouldn't be loaded with rather, let's say, low resistance capacitance, low capacitance. You're not talking about like probe card? No, not probe card.
I'm assuming this is the equivalent of like an active probe, like an oscilloscope, but a much smaller tip.
No. There's a company named Pico Probe,
Right. Yeah.
They fabricate active probes. So specialized micromanipulators with some electronic circuitry buffering the probe tip, which is a capacitive sensor, from the equipment you're connected to. So those are usual. Usually you've got passive probes and active probes on a probe station if needed. And those are pretty much like manipulators.
Bigger.
Ken Matthews. He's our applications engineer.
I'll take a note for you. Let's see if we have anything.
There's the house.
Yeah, it's right.
How do you see my work like this? Oh, it's really wide, it's not good.
Homework here.
But you cannot fabricate this here. It's just
I guess it will be maybe in the basement, the new lab. I guess he did it on the CMC. It's just testing and characterization.
This is the one.
Yeah, so I can record this.
Okay, yeah, he's trying to say.
Just let me Ty,
Yes.
will you also show us the RF probes or just DC probes?
We can
Because we don't know how to set the RF probes.
we can attach a couple RF probes. So we just won't. I don't think we'll touch down the RF probes, but we can show you what they look like.
I mean, at least how to just adjust with the lever
Sure, we
and.
can. All right. So did you guys actually take a look at the probes?
Can we just take a quick
Oh man, this is like breaking the seal. So what we can do is like we can attach one to one of the probe positioners. I'll show you guys what it looks like under the microscope. I guess if you really want, we can show you how to use them. I guess you kind of need to show me, right? How to use them.
Yeah. Usually there's somebody in a group that has used them before, but there's nobody here that's.
You must have used
That's what
RF probes before, right?
That's
Just RF probe. It's a GSG 100 micron probe.
I kind of defer to the customer user, but we could, if nobody's done it before, then we absolutely should.
How expensive are these ones?
No, I've not used these before.
Oh no, but just RF probes in general. They're under $1,000, so they're maybe like in the So they're enough that you're like, oh, I don't want to damage them.
I've got another question for you. How do you block these holes for vacuuming if not needed? For example, if you've got a tiny chip and you need just one single hole to vacuum, how do you block the others from
There's a
vacuuming?
latch on the side.
Mhm.
You can see on the side here. It says C2468, I think.
Yeah.
Yeah, so you can slide that
Okay.
back and forth.
The C even is 4 of them. For smaller
yeah.
ones.
The C would still be the 4, the 4 dots in the middle. Then 2 would be 2 inches radius.
2 inches, yeah.
No, diameter, yeah, because I'm like, this is 6, so that would
So
make sense.
for the smaller ones, go from the smaller ones.
Yeah, there's no way to do just one hole. But the tall gentleman, he made a good point. You could technically, you could block the other 2 holes. There's 3 holes.
That's not configured yet.
Tape or
So
something,
our
just so
plan
that
was
you get
like
more
we'll be
strength
doing
in the
something
one.
here, and by this time we'll make
That would be the
configuration
best way
half an hour
to,
probably.
as kind of a.
Yeah.
Actually, really is somebody else had one. It's gone now.
Maybe I can
Kind of
just figure
hold
check
with
how long
multiple
it will take to
devices on it. So it was a larger piece, not like a holder that was holding a smaller die. Something like that you could put on like a small wafer or something that you could attach it to, and then you could vacuum down that. That really was a single die. It's tough. It's tricky. Very, very tricky to do. So if you had like a small wafer or even a small piece of wafer that you could glue it down or tape it down to, that works the best. And then you can vacuum that down.
Usually when you order a chip, when you design a chip, they can be made really small, in the order of, let's say, 1 millimeter by 1 millimeter, or 1.2 by 1.2. So I was hoping that just a single hole in the center would be able to vacuum such a tiny chip, not just the 4 of them in the middle. So do you have other designs for the chalk with different,
Layout
let's say,
holes.
layout of the holes?
No, I know with this truck, I think the spec is like 5 millimeter by 5 millimeter is the minimum die size. By the chart.
No, that is
The data sheet, yeah.
that is for rich people.
For rich.
5 millimeter by 5 millimeter
Yeah.
costs
yeah,
a lot.
yeah.
So
Do you have a solution? Maybe you could attach it to another substrate somehow?
usually I don't like to do anything with the bare die. You just put it on the chalk, do the tests, and put it away, or use it. Sometimes you test the chip first, and then put it on a substrate, on a platform, to make another system, right? So gluing it on anything would ruin the backside of the chip. So that is a problem from the microsystems development perspective.
What about just covering the other 3 holes then, just like the other gentleman said?
You can do that, but you're still stuck with, vacuum, whatever the vacuum level, the diameter of that hole, PSI, it's pretty much you're only going to get so much holding power out of that one hole. So you can pull as much vacuum, but you're limited as to how much force that one hole is going to draw. It's just physics. What about blue tape? Could you use like a blue tape where you could just put the tape on the chalk? It's a double-sided blue tape.
Double-sided.
You can do that. It's like a wafer. They use it
Have you ever manipulated a chip, a die, a bare die? It is not that easy.
Yeah, I'm trying.
So let me ask you this. I think there's 2 things at play here. Is your die small, right? You said one by one. So the fact that it's 1 by 1 is the issue that you're worried that there's not enough vacuum strength in the one hole, or are you more concerned about?
Well, when you've got 4 holes
Right.
vacuuming at the same time, if you put your die on one of them, then the strength is not enough because the other 3 are vacuuming and right.
Okay.
So there's no purpose for that vacuuming if the other 3 are vacuuming. It won't be stuck.
Well, that's
as
why.
strongly.
Yeah, I thought the set was actually good. So why not just cover the other 3 holes with tape mesh? If that's your concern, then that should solve the problem.
You can try it. Is it going to be strong enough to do it?
No, but we're talking about 2 separate things here. So you're talking about the actual strength of one vacuum, where he's saying the strength of one is present in 3 holes, right? So that's why it's, you know what I mean? Like it's two separate questions.
Yeah, you're absolutely right.
See, if you've got 4 holes and you wanted to cover 3 of them with a piece of tape, right? Like this. Then you have to align your die like this, right? This is why sometimes you want to put the die in this orientation so that you easily get in touch with the pad. It's not an easy job to get connected to the pad or the points on the chip that easily. So sometimes you have to rotate the die so that get in touch more comfortably. So
Well, we
putting
can
a piece of
rotate the
chalk
itself.
A little, 5 degrees.
5 degrees.
Oh, it's 5 degrees.
No, that is not.
It's more for fine line.
But I guess what I'm getting at is, I agree with you. If you're covering, if you just have a piece here and these holes aren't covered, yeah, it's not gonna, it won't hold. That's why I do think, putting tape on somehow is probably the best solution. I don't know if it's the right solution, but it's probably
No.
the best way you're going to get to actually.
The probe stations are used